Hey guys, welcome to this another Tech Bite with Cloud Devta. Today we will talk about containerization and Docker. We'll talk about the evolution of app deployment from physical server to virtualization and then finally to containerization. So with this discussion, first let's talk about an app deployment scenario for physical server. So before the virtualization was there, applications was installed on a physical server, and to have at least a moderate utilization of a physical server, multiple apps were installed. So here an example, if we see, there's a physical server on which there are 3 apps which are installed. These apps have dependencies as well. These dependencies can be a module or an OS library or a similar working module. Now app 1 and app 2 are dependent on dependency D1, whereas app 3 is dependent on dependency D2. Now if you make any changes on app 2, there might also be a requirement of making some changes on D1 as well. So with these changes, application 1 can be disrupted. It might impact app 1 and it might also stop working completely. So thus, without virtualization, we used to have such issues with physical server implementation of apps. Then came virtualization, which improved this. Now, what we had was over a physical server, instead of installing an operating system like a Windows server or similar Linux, we came with the concept of hypervisor. So hypervisor, over this, you can actually create virtual machines. So here, a similar deployment is there, but instead of installing these apps on the physical server directly, we are first creating 3 virtual machines, and on each of the virtual machine these apps are installed. App 1 goes on virtual machine 1, app 2 on VM2, app 3 on VM3, right? Similarly, the dependencies that were there, these dependencies are also installed. So D1 is common for app 1 and app 2, but they're installed separately on V1 and V2, VM1 and VM2. Similarly, VM3 has own dependency. So now if you make any changes in the application, there will be no impact to any other application, because every change or any impact is isolated. The VM is itself acting as a separate compute environment like a physical server does. So there is no point or there is no chance of any impact. This model is quite great. I mean, no issues, applications are running quite well, and a physical server is even well utilized as compared to the previous use case. The only challenge with this model was, imagine if the application is of a small size, then even reserving one virtual machine is a waste, because the utilization of that much virtual machine might not be even more than a 30 to 40%. So in that case, how do you utilize a virtual machine well? And some people might say you may reduce the overall size of the virtual machine, but going beyond certain value of vCPU and RAM actually deteriorates the overall performance. So you need to have at least a minimum compute power to a virtual machine, but in that case there might be wastages. Thus we come to the third model, which is the containerization. So this is the next generation of application deployment in the current generation. In this model, now instead of installing these apps individually on these computers, what we are trying to do is we are installing these apps on a container. So these are actually embedded into a container, and these container can be put into a virtual machine. So there will be a software on the virtual machine to be able to manage these containers, but other than that, or to create the container, but these application itself are not going onto the virtual machine directly. In fact, they're embedded into the container. Now you can have multiple containers on the same virtual machine, and all provide the isolation from other containers, such that if you make any changes in, let's say, application 1 and that application 2, which is all on the same virtual machine, that will not be impacted because it's in a separate container altogether. So if you see, container of course is a package of OS, system libraries and applications. So unlike a virtual machine or physical server, which is heavy in terms of usage, which has a lot of different utilities, containers have very minimalistic overall shape, which has only the OS package, that too at a minimalistic level, the application and the system libraries. So this container, you can call that, or you can treat that as a mini virtual machine, because it is very similar to how a virtual machine works. The only difference is now multiple virtual machines which resides on a physical server Here you have multiple containers now residing on a virtual machine. So you can see another example here. You can have a Linux VM as a one of the virtual machine running a physical server, and over that you can run an Apache web server. You can have Nginx. You can have another Apache. So multiple containers can run on this virtual machine, which will further increase the utilization of virtual machine, and you know the physical server itself gets much more well utilized. So this is how container or containerization is a very powerful technology. And today, if you talk about the application deployment, most of these apps are deployed on containers, which makes it much more efficient, as well as from the management point of view also it is quite good to manage. Now, if you must have heard about Docker. Docker is one of the tool set which can be used to create and deploy these containers that we were talking about. So we mentioned that there are containers. So these, how do you create these containers, or how do you deploy or run application on a container? That is done through one Docker. Docker is one of the tool. I mean, it's not the only tool, but yeah, one of the best tool available today. It's just, so when you talk about in this whole scenario, so container is a standard unit of software, and this container contains your code and whatever is required to run your code, maybe a subset of OS as well, right? So another question, why Docker? So the reason that we are using Docker is that Docker helps you to containerize your application and make it easier to maintain and deploy it. It is one of the best tool available in the market and easier, to use. A lot of developers and a lot of admins do prefer to use Docker because of its ease and because of its availability, integration, and all other important aspects available to it. Again, it's like, this whole concept reduces the size and cost of your infra, as less virtual machines now will be required. And you can also create some common Docker images for apps, sharing common dependency in OS, which will further easy make your task easy. Now, if since you have deployed the same application in different computing environment, it also reduces the blame game that you have in the scenario that but it works on my computer. So now, if you talk about this container, these containers are also mobile. I mean, container one that you see here, that can be easily migrated to VM2 if VM1 is not working properly. So this whole concept gives you a lot of flexibility, improves your efficiency, and is a great concept overall. Okay. So thanks for joining this session. In the next session, I will be coming with a practical implementation of Docker, and then we will move towards Kubernetes. That is one of the, Docker is one step towards containerization, but Kubernetes is the bigger picture. So we'll talk about that. Thanks for joining. I'll see you next time.